And so it begins, which is the theme of this year's graph. Graphs, yeah, really is. Graphs of trig functions. Exact values of special angles. So we've done these, right? Use the unit circle to complete the table below by stating the exact values of the primary trig ratios of the given angles. So I'm going to shrink this thing down so we can, let's say 75%, maybe a little. Almost fit it in. So we have exact values, right? So let's just fill in the exact values. So sine of 0 is 0, 1/2, root 2 over 2, root 3 over 2, 1, and then we count down, root 3 over 2, root 2 over 2, 1/2, 0. And then it moves into quadrant 3 where the sign becomes negative, so we count up but in a negative fashion, right? So we're always going from 0 to 1 or 1 to 0. So this goes 0 to 1, but it's negative 1/2, negative root 2 over 2, negative root 3 over 2, and negative 1. And then we go from negative 1 to 0, counting, right? And anytime you're going from 1 to 0, it's root 3 over 2, root 2 over 2, 1/2, and 0. And anytime you're going from 0 up, so this is negative root 3 over 2, negative root 2 over 2, negative 1/2, and back to 0. The cosine function starts at 1 and then works its way down. So 1, root 3 over 2, root 2 over 2, 1/2, 0. And if you're 0, then you're going to have to go negative, right? And as cosine moves into quadrant 2, it's negative. So negative 1/2, negative root 2 over 2, negative root 3 over 2, negative 1, right? And then we go from negative 1, we're going back to 0, but they're negatives, right? So you got to go negative root 3 over 2, negative root 2 over 2, negative 1/2, 0. And from 0 up to 1, we're now into quadrant 4. In quadrant 4, the cosine is positive. Okay, and I'm just counting my way up. All right, and then here are the decimal equivalents, right? Which is sort of the way of knowing an exact value without knowing an exact value, right? Like root 3 over 2 is 0.87. So if you're sitting there and you can't remember, what's the exact value, sine of 60 or something, you hit sine 60 in your calculator, it says 0.877 something, and you go, oh yeah, that's root 3 over 2, right? 0.7071, which is rounded to 0.71, that's root 2 over 2. 0.5, that's a half. Okay, and then we get into tan, so it's tan. Tan is just sine over cos, right? It's y over x. It's really just sine over cos. So 0 over 1 is 0. Now remember, when I go 1 over, to do this, right, you're going to go a half over this, but this guy flips and the 2's cancel. So it's really just the numerator. It's 1 over root 3, which is root 3 over 3. This is root 2 over 2, which is 1. This is root 3. 1 divided by 0 is undefined. This is negative root 3, negative 1. This is negative root 3 over 3, and 0 divided by negative 1. 0 divided by anything is 0. This is positive, right? These guys are both negative, so this is negative root 3 over 3. This guy is negative 1. This guy, these guys are positive, he said, and then proceeded to write negatives. So root 3 over 3, 1. This is root 3. Divide by 0, undefined. And back into quadrant 4, where this would be negative. So this is negative root 3, negative 1, negative root 3 over 3, and 0 divided by 1 is 0. So those are the values, right? These are the exact values. But if you want to graph this, these are the decimal equivalents. Okay? And so now, we're just going to kind of blast through this and graph it, right? Because, I don't know, probably should have been done on Monday or Tuesday. Yeah. Use the table of values to sketch the graphs of y equals sine theta and cos theta on the grids below. Note the grid is scaled from negative 360 to 360. Okay, so let's do sine theta first. Let's do sine theta first. Let's go page width. So blow this up a bit. Just do one at a time. Okay, so you can see the numbers there, right? So I'm just going to go 0 to 360 first, right? And then I'll show you how we can just kind of back it up a bit. So you've got 0, 0. We got to figure out the scale here. What's the scale? So we got 1, 2, 3, 4, 5. We got 6 ticks to go to 90. So how big is each tick?
1/6.
1/6 of 90. which is 90 divided by 6, which is 15. Okay, so, and we're going 30, 45, right? So 30, so 15, 30. Okay, 30 is 0.5. 45, that's the next one, right? It's 15 degrees over. So 45 is 0.71. Then 60, and 60 is 0.87, we almost there. And then we go at 90, right? There's no 75, we got 90, which is 1. And then we start coming back down, so 90, not 105, but 120, and 120 is the same, right? There is some symmetry here. And then we've got 135, oops, which is there, not quite that big. It's above 0.7. And then we've got 165, which we don't do, so we got to skip over here to 150. Oh, sorry, no, this is 150. Which is here. We don't do 165. Then we got 180, which is 0. And then we go over 30 degrees, right? 210 be negative 0.5, and then 45. So we move over 15 to get to the 0.7, another 15 to get to the 0.87. Then we get to 270, so we skip over a couple. We're down here, and we just kind of, again, symmetrically repeat that, right? I mean, 30, so 300. And then 315, and then 330, and then back to here. Okay, now that's all I'm going to graph. And then we join that with a smooth curve, right? So sine is a smooth curve, not a bunch of straight lines. It doesn't V, right? In other words, no, it just smoothly comes over the top. Okay, it doesn't come up to a sharp point. So there's no sharp points on here, right? It's just a very smooth curve. Theoretically, going through all the points, I got missed a little bit there. But. And if you go do the negatives, it's just a reflection in the y-axis, right? So from here, we can't start going up, right? We have to come down. And so all I'm going to do is just hit the highlights here, which is these guys. And use my mad sine curve sketching skills. Just kind of sketch that in, right? And it's a little sketchy, but pretty accurate. So in theory, you would plot the rest of those points and then graph that, right? So here are some important takeaways for sine. The period, which is the amount of time it takes to go through one cycle. One cycle is I've gone through all the values, right? So I go from 0 to 1, back down to 0, down to -1, and back to 0, right? Back to where I started. That's one period or one cycle. So starting here and ending up here, right? I end up in the exact same spot. Same thing, I could start down here. So I'm starting at the bottom, and I got to get back to the bottom. That's one cycle, right? It's 360 degrees. Period of sine. It's split into 4 parts. The 4 parts are each 90 degrees, right? 1/4. 4 parts, 360 degrees is a full cycle. A quarter of that is 90. So you start at the midline. This is the middle, right? You start at the middle, you climb up to the maximum. You come back to the middle, down to the minimum, back to the middle. Okay? And all this really is mostly next year stuff. But that's the idea behind the sine curve. You're going to get very familiar with this curve. Cosine curve. I'm going to do the short one. So the short one is cosine starts at 1. At 90 degrees, it hits 0. 15, 1, 2, 3, 4, 5, 6, 9. 1, 2, 3, 4, 5, 6. At 180, it hits -1. At 270, it hits 0. And at 360, it's back to 1. And going the other way, if it starts at the top, it's got to head back down. So at 90, it's at 0. At 180, it's at -1. At 270, it's back to 0. And at 360, it's back to 1. And you want to sketch that. So you're just starting up here, dropping down smoothly. Okay. And there's cosine curve. Now, if you want to take, you can go back in and just sort of put in the other points. So this isn't necessarily totally accurate. But that's kind of the shape, right? So just have that in mind. Okay, and you can make your sketches better by filling in the other dots and that. So you might want to do that at home or something. A function is said to be periodic if it repeats itself over regular intervals. Are these periodic? Yes. The period is the length of the interval of the domain over which a graph repeats itself. So the period is 360. And you need a degree symbol, right? That actually is units, especially next year when you get into whether it's degrees or radians. Okay, you need to make sure you have units. What? We don't do radians. Not this year. Sinusoidal data is periodic data whose graph can be represented by a wave pattern. Do these look like a wave? Yeah. The domain of both graphs. Any value, any angle that I can't find the sign of. I mean, we know we have negative 360 to 360. We also know coterminal angles, so you can keep adding 360 to any of those. So is there any number I can't do sine or cos of? The answer is no. So it's just theta belongs to the reals. Okay. You can throw any number in there. Doesn't matter. You put in 2,875,316. If you subtract enough multiples of 360, you'll get back to a number between 0 and 360. For both graphs, what's the maximum? How high does it go? And what's the minimum? Therefore, the range of both graphs is? Okay, so the y value lies between -1 and 1. Okay, again, very important characteristics. Graph of the tan. Now tan is different. Use table of values on the first page to graph y equals tan theta on the grid below. You'll have to supplement the values in the table so you can draw an accurate graph. So, view. So, let's take that down. So, yeah, it's good enough. Now you notice the scale, right, goes to -10 and 10. Right, so tan doesn't have the same range, right? It's not between 1 and -1. Okay, so let's start at 0. The tan of 0 is 0. Okay, what's the next number that we have a tan for? I don't know tan as well as sine and cos. So we've got tan of 30 degrees. What's that? Root 3 over 3. So that works out to, what's the decimal equivalent? So 1530. It's about like 0.5, 0.6, right? It's pretty small.
Yeah, 0.57.
Right, it's in your table, right? It gives a decimal next to it. So you don't have to. Okay, then next we have 45 degrees. What's the tan of 45? 1. That's actually a very important point. Okay. Come in handy next year. You know the tan of 45 is 1, right? And the scale here is this is 1, 2, 3. It's by 1. Okay, tan of 60 is root 3. So root 3 decimal equivalent is like 1.7-ish. So that's there. And you know, it says you got to sub, because the tan of 90 is infinity, right? Which really means we have an asymptote there, right? We have an asymptote because tan is y over x, and the x value is 0 at 90 degrees, right? So you got an asymptote. You're trying to divide by 0. So what's the tan of 75? Get your calculator out, go tan 75. It's not a calculator, it's a cell phone. Get your calculator.
3.73.
Tan of 75 is 3.73, so that's about like here. All right, so how do we go from like 75 degrees to 3.73 and 90 is like infinity? What's the tan of 80 degrees then? Oh, now we're at 5. We're like here. Okay, what's the tan of 85 degrees? I mean, at some point it's got to start getting big. Okay, so then we're up here now. So here's what happens with tan. This is just 0 to 90. You get this idea. Now with tan, it's actually better to go the other way. Right? So we'll go to the negatives. Now the negatives here, right? Negative 3. That just takes you into quadrant 4. The values are exactly the same as these guys, right? Only they're negative, right? So at 30 degrees, the tan is negative 0.6-ish. So this is at negative 30 degrees, we're here. At negative 90, we're like down here. So at negative 90, again, we've got an asymptote going on here, right? Because we're trying to divide by 0. And remember, this is 270 degrees, right? Negative 90 plus, so it's the same as the 270. So you can look in your table at from 270 to 360. This is 270. This is 360, and this is going down to 270. Okay, and 45, 1, 2, 3. So we're here at 1. Okay. So basically, just kind of looks like this. It's basically kind of a reflection of this, right? And it's reflected twice. Once in the y-axis and once in the x-axis, right? So it's reflected over. So if you take this branch and just imagine, okay, flip it like this, and then flip it down. And never use the word flip. So reflect it in the y and then reflect it in the x. Okay. Now, tan has a period of 180 degrees, right? That repeats. So this is one complete cycle of tan, right? From negative 90 to 90. So the tan has a period of 180, so we just go to 270, and there's another asymptote, and 180, that's kind of your middle, right? So this whole thing just kind of, imagine it just shift over, and you basically have, let's get the 1.123. So there's positive 1, 1, 2, 3, and there's negative 1. So I just need something that looks like this. And then I do the same thing going over here. 270, there's a 0 here, 1, 2, 3, there's a 1, 1, 2, 3, there's a negative 1. And then there's a 0 here, and it's going to start down at the bottom and work its way up. And here, there's a 0 here, and it's going to have come down, right, because that's the down part, so it's going to do this. Right, and then go off the page. And that's what your tan graph looks like. Okay, so tangent. Is the graph periodic? So does it repeat? Yes. What's the period?
90, 180.
180. Why is the graph not sinusoidal?
It's not a weight.
Not a wave. What's the range? All real numbers. Yeah, it's going from negative infinity to positive infinity, right? So it's all real numbers. Graph has vertical asymptotes at theta values where... What?
Sorry, can it not be 0?
Can it not be 0? Go ahead. Don't throw a negative in there. Ask the question again, but just say, can it be this? And then I can say yes or no.
Well, if it can't be 0, then 0 is a real number.
It is.
Yes, 0 is a real number, and it can be 0. And that's why we said y belongs to the reals. So can you not ask questions with not in there? Because if I say yes, what does that mean, right? Whenever you say, can it not be? Yes. Does that mean it can't be or it can be? Right? Don't ask questions in the negative, right? Just say, but isn't 0 about? Yes. Okay. All reals. Okay. The graph of y equals tan theta is vertical asymptotes where the theta value is what? Where's the first vertical asymptote? 90. Where's the next one? It's where they all are. So 90 degrees plus 180n, where n is an integer. So it takes the first positive asymptote and then add multiples of 180. Right? If n is an integer, it could be positive 1, it could be negative 1, it could be positive 3, it could be negative 3. Oh, wait, that's the general expression. All right, so that goes down here. 90 degrees plus 180 n degrees, where n belongs to the I. Just put an arrow down there, and then up here. So we had what? Negative 270, and negative 90, and 90, and 270. That's the general. So what's the domain of tan theta? Here's how we express this domain, right? We say theta cannot equal. Actually, here it should say theta is, so theta cannot equal 90 degrees plus 180 n degrees, where n belongs. So when we say the domain, we say what it is, and when we say the asymptotes, we say what it, or sorry, when we say the asymptotes, we say what they are, right? 90 plus 180 n, and when we say the domain, we say you can't be this, right? So theta is not equal to 90 plus 180n, right? That takes care of every possible place where you would be dividing by 0. Okay.
Questions, comments, concerns?